to finish this series of videos about random sets, I want to talk about selection. So far what we did was building a random set from regular random variables. So in this video, we are going to actually go sort of in the opposite direction. Okay, so suppose we have a random set. Okay, so let X be a random set. Okay. Let's pick for every omega just one point out of the set. Okay, so let X be a random variable, point valued, such that X of omega is an element of X omega. Okay, so this is a set in RD. This will be just one point out of that set for every omega. But the important thing here is that I don't just pick a point out of the set. I do that such that what I will get here, this X of omega, okay, is a measurable mapping between omega and RD. Okay, so this is indeed a random variable that satisfies the definition of a random variable. If I can do that, okay, if I did that, okay, this is, okay, a selection. Okay, X is called a selection. Or for out of X. Okay. So again, the point here is that I will pick one point out of the set, okay, and I do that in a measurable way, such that what I get out of it is indeed a random variable. Okay. So the question is, can I do that? Okay. For the examples that we discussed before, of course we could do that. Okay. So if X is just equal to small x like that, well, I'm always going to pick that point exactly, and by definition, by construction, that's going to be a selection. Okay, so X is a selection. Okay, when X was equal to y lower, y upper, this interval, okay, I could pick any of these two. Okay, so YL itself and also y upper are selections. Okay, and from what we know about random variables, we know that, for example, the average of these two will be, or any convex combination of these two will be a selection, and so on and so forth. So Aumann showed that not just for these two examples, but for every random set, there exists at least one selection. And therefore, we can call the set of selections, okay? So we said let cell of X be the collection of all selections of X. Okay, and that's a non-empty set. Again, not just for these two examples or other examples that are constructed from the beginning from regular random variable, but just any random set that satisfies the definition of random set that we saw two videos before. Okay, so conceptually you can think about random sets as a collection of random variables in them. Okay, so it's a collection of a lot of random variables that are collected together into the thing that we call a random set. If you want to draw a picture, okay, it's an abstract, representation of it. If that was our omega, okay, and X, capital X, would be this some mapping that look like this, and it can be like that, and maybe sometimes it becomes just one point, and then it opens up again, and so on. So for example, for this specific, let's say, omega here, okay, the value of the random set will be this set. Okay, and then here they're all interval, but it doesn't have to be like that. So what I will do in order to construct a selection, I will pick a point, and suppose I can do that in a measurable way. So I say, okay, for this omega, I'm picking this point, and then this point, and here I don't have any choice, but here I pick this point, and then I go here, and this small x, that will be a selection out of the random variable. And I could do that in many, many ways, as long as I do that in a measurable way. In that sense, I created a selection, okay? And that's what a selection out of a random variable is. Thank you.